I'm going to explain why the integral test does not apply to the series sum from n equals 1 to infinity of 2 plus sine of n all over n. So the conditions for the integral test were being continuous, positive, and decreasing. Now, for continuity, the only issue is with the denominator being 0, which in this case it would have to be n would have to be 0, but we're starting from n equals 1 and going to infinity, so that is not an issue. Okay, the next case is when a sub n is positive. So 2 is positive, n is going to be positive since it's 1 to infinity. Now sine of n is between -1 and 1. So the smallest it can be is -1, which means that 2 plus sine of n is going to be between 2 and 3. I'm sorry, 1 and 3. So that is always going to be positive. The numerator is going to be positive. We already said the denominator is positive, so it's all going to be positive. And the last one is it decreasing. So here we can come up with an example to show that it is not decreasing. Now if we let n equals 5, we have 2 plus sine of 5 over 5, which is about 1.808. And for n equals 6, plug in n equals 6 to get 2 plus sine of 6 over 6, and that's about 1.953. So as you can see, n increased by 1, but a sub n ended up increasing as well. Well, according to this third condition, it has to be decreasing. So we would expect this number to be smaller than 1.808, but because it's larger, we cannot use the integral test. Okay, next question. We want to use the p-series test to show that the following series are either converging or diverging. Okay, so let's look at the first one is 1 plus 1 over root 2 plus 1 over root 3 plus 1 over root 4, etc. We can just rewrite this as the sum of 1 over root n from n equals 1 to infinity. And if you're having a hard time figuring this out, you can pretend like this is 1 over root 1. So this would be when n is 1, this is when n is 2, n is 3, and n is 4. So hopefully that makes it obvious. That's how you get that. Okay, so here we can also rewrite it. Instead of having the square root, we can just say 1 over n to the 1/2. And for the p-series, it has to converge if p is greater than 1. But because p is less than or equal to 1, it's going to diverge. So p is 1/2, therefore it diverges by the p-test. Okay, let's look at another one again. So this one is going to be similar, but we introduce a number in front of the square root. So this one, we can write this out as 1 over 1 times root 1. So this would help us figure out what the pattern is. So the first case would be n equals 1, n equals 2, etc. So that would just be 1 over n times root n, starting from 1 to infinity. So I can rewrite this as 1 over n to the 3/2. And because p here is 3/2, it's greater than 1, this series is going to converge by the p-test.